Good morning. Today we're going to talk about parabolas. So this is the first video of 2 videos about parabolas that I am making. So this actually is the second video that you should be watching that I posted for you. So, all right, so a parabola, as we know, looks like a U either going up or it's going down or it's going left or it's opening right. So we're going to talk about some different forms of the equation. So I'm going to go kind of fast in the beginning because we already talked about this kind. All right, so when you were in Algebra 2, you had parabolas in this form, and you graphed them, and then you looked for where they turned or where their vertex was. So if you labeled the coefficients in front of the variables a, b, and c, you could easily find the vertex by using this formula. And so the vertex for this, or the x value of the vertex for this one, would be -7 over 2 times 1. So -7 over 2. And then you would take that value of that x value and plug it back in and go and find y. And then let me go ahead and calculate that. Okay, so once you calculate that, since this is about -3.5, I put that in for x, and I got my y value to be -2.25. So we go and we graph that. -3.5 and then -2.25 should be right about approximately right there. All right, and then we know other things. We know that since this number is positive, because it's an A, oops, sorry. Okay, since the A was positive, it's going to open up, and so we know it's going to open kind of like that. And we could do some other things to find our intercepts or something. We know that the intercept, the y-intercept, is going to be at 10, so my drawing is not quite exact. So I know my y-intercept is 10, so I'm going to draw a y-intercept at 10, and then draw it so that it, ooh, I'm still not drawing it very well, but you get the idea, okay? So, yeah, we're not really going to use that form very much in math analysis. I just kind of wanted to show you that. So let's go on and look at what you did when you were also in Algebra 2, and we still use this form. It's called the vertex form, right? And I think that in the video that you watched previously, he called it the preferred form, okay? So if you heard him saying preferred form, that is the form he was referring to, because it was very easy to find your vertex from the H and the K. So if you heard him saying preferred, it just means vertex form. All right, so here's what we're going to do with that. So you could just take this, now that it's in this form, and you can graph it. Now your center is going to be at 4, not your center, but your vertex, and 6. So we know that this vertex is going to be at 4 and 6, so we go over 4 and up 6. 1, 2, 3, 4, 5, 6. And there we go. All right, and then we could make it a very fat parabola here, and or it's a skinny parabola. We'd have to work it all out in order to figure out what the y-intercept is, because this is not actually going to be the y-intercept anymore. That's now part of your vertex. So you'd have to go and FOIL it and work it all out. But basically this means it's going to open up. It's going to open up along the y-axis, and it's going to kind of be a little bit thinner than normal, okay? And that's what it's going to look like. Now, let's go look at the next page. So here you got it in vertex form, and we are going to work it down to another form that we now call standard form when we're in analytic geometry. And so this is the formula you would use for standard form. Take a minute and copy that down, and then I'm going to show you how we work it down. Okay, so I'm going to work this down so you can kind of see how these variables relate to each other. So first thing I'm going to do, you notice the squared term ends up being on the left-hand side. So I'm just going to go ahead and switch these around right now with the symmetric property, meaning I'm just changing them around from side to side. So now the y goes over to the right, and all this other stuff goes over and stays on the left. All right, now let's go and work this out. So I'm going to subtract k first. We're trying to get down to where we're solving just for x minus h squared. Subtract k, so you're left with a times x minus h squared equals y minus k. All right, we're very close to getting this done, right? So now we're going to go ahead and I like to say we're going to multiply by the inverse in order to cancel these out. 1 over a times a is going to cancel it out, and then we're going to put a 1 over a on this side. All right, and so that becomes, these cancel out, and we're left with x minus h all squared equals, and I'm going to switch these around with the commutative property, 1 over a first, y minus k. So now we have another variable involved, and it is called p. And so when you see this in math analysis books and higher math books now, we won't necessarily refer to that factor that's going to determine how it opens up as a. We're now going to determine how it is by p. So basically 4 times p is equal to the same thing as we would have said 1 over a. And we'll do this with numbers in a few minutes. P actually helps us decide how far it's going to open up, so it makes it a little easier. Okay, so let's try it with numbers because it might make a little more sense with some numbers. Before we do that, actually, let's go ahead and if you want to go and copy this down, these are the formulas that go with a parabola that opens up and down. All right, so your vertex now is still h and k, but remember now they're both being subtracted in this case, so it's kind of like that circle formula. It looks more like a circle formula the way that it's written. And then our focus, we still have a focus, and I'm going to color code it red so you can see the focus is red. And let me put my vertex as blue since they have it blue on the picture. All right, and I'll color it blue. And the focus is red. Now because it's going and opening up and down on the y-axis, we're going to add p to our k. Okay, so we're adding it to our y value. So we're adding the p to the k. Your axis of symmetry is where it divides in half, and that is just the h value of your focus, okay, or I'm sorry, of your vertex. Comes out and becomes that. And then we have a new thing called a directrix. All right, and a directrix is a line that goes underneath on the outside of the parabola, and you're basically just going to be taking it away from whatever your focus value is. Okay, I'm sorry, your vertex value is. So if you're opening up on the y-axis, you're going to add or subtract it from k. You're going to subtract p from k. So there's the formula for that. Probably it would just be easier if you just copy the formula down and don't listen to me. All right, let's try one when it opens up the other way. Now this one is going to open up along the x-axis. All right, so let's go and see how we can work that down to make it look like the standard form that we're going to be using from now on. So I'm going to switch these around again. A times y minus k squared. Okay, symmetric property. Now start moving things away. So move my h over to the other side. So a y minus k squared equals x minus h. All right, multiply both sides by 1 over a. So 1 over a times this times y minus k squared equals 1 over a times x minus h. And so these two guys are going to cancel out, and we're left with the same exact form. So this is going to open up left and right, depending on what p is. And then here are your formulas for your vertex, parabola, and I'm going to go ahead and I'm going to color code them so you can see what I'm talking about. So let's make the focus red again. All right, there's your focus, it's red. And then your vertex, we'll make it blue again. And your axis of symmetry now. Notice it's going, it's the same direction as the way that it's opening up. So it's going to be going along the x-axis. It's parallel to the x-axis, but you're using the equation y equals because it's a horizontal line. And then the very last thing is our directrix, and that is the line that goes perpendicular. There, that's what I was trying to say. Perpendicular to the axis of symmetry, and this time it is added or subtracted to the h value. All right, so we are basically subtracting it from there, or you're adding the opposite if you want to look at it that way, because sometimes it's a negative sign. All right, let's try one with numbers. Here we go. So you've got your vertex. We're going to figure out the vertex and all this good stuff for this one. All right, so our vertex is easy. All right, we know that it's going to be 4 and 6. If you want to go and work this down first, let's go work this down first. So we're going to say y minus 6. Oh, let's go switch these around first. We want our squared term to go first. So we're going to switch 2 times x minus 4 squared plus 6 equals y. Now let's go subtract our 6 and work this down. And then we're going to multiply by the reciprocal here, multiply by 1/2. So we get x minus 4 all squared equals 1/2 y minus 6. All right, this makes it much easier to figure out, because now we know that 1/2, okay, remember this is not p, 1/2 is equal to 4p. So if 1/2 is equal to 4p, we're going to we're going to divide everything by 4, all right, or multiply by 1/4. P is only equal to 1/8. So we've got a tiny little change here between the vertex and the focus and the directrix. So the axis of symmetry, let's see, which way is this one opening? It's opening up and down, right, because that's y. And that's because it is a positive 2. So it's opening up and down. So the axis of symmetry is just the x equals 4. It is that value right there. Go back to your formula that you already copied down. All right. The axis of symmetry on this one is x equals the h value. Okay. So x equals 4. All right. Our focus is going to be at h, and then k plus p. Go back and make sure that the formula that we did is correct, okay? So the focus is at h and k plus p. So let's go plug that in. So our focus is going to be 4 and 6 plus 1/8, okay? You can just do 6 and 1/8 if you want, or you can go ahead and write it as a decimal, 6.125, or you can write it as an improper fraction. All right, so far we've got our vertex, our symmetry, and our focus. Our directrix is just going to be another line. It's going to be perpendicular to this line, so it's going to be y equals whatever k minus p is. Okay, so I'm going to use a calculator so I can be sure of what those decimals are, because it's kind of complicated. So if my k is 6, I'm going to subtract 0.125 or 1/8, and I get 5. So y equals 5.875. All right, there we go. So now we've got all of our equations and all of our critical points. All right, so what do you notice about this parabola? You notice that the focus and the directrix are equidistant from the vertex, okay? If the vertex is here, and if the focus is just 2 away, the directrix line is just 2 away in the opposite direction. So that helps you when you go to graph it. All right, and so I wish we would have had an easy one to graph in this one. I do not want to graph that one for you. You'll get confused. All right, so let's go backwards with this. let's write the equation of a parabola that has, oh, we're about to run out of time. I'm going to save this